All right, I wanted to extend some of the work we did today to just draw as tight of a connection I could to, well, the work you did to, like I was leaning us toward, the idea to extend the definition of trigonometry ratios so that we can use any angle. So the first thing I want to, just following the sequence and the way I assigned the homework, when you completed the task at certain points in time, you were asked to find a formula to figure the height off the ground for any angle in the first quadrant, any angle between 0 and 90 degrees. Then I asked you to extend that and begin finding a formula for each of the 3 other quadrants. I'm not going to try to necessarily show those results, but because there's a bunch of different ways you could come up with them. Some people will use sine and then cosine in different quadrants. And again, there's just some other ways to go about it. The main point here being that as you're working, it would be frustrating to have to sort of create a different approach for every different quadrant or every different set of 90-degree intervals that you're using for trig. Some form of piecewise function would be frustrating. Again, like if you had to figure out a situation where this rotation was 112 degrees, you know you can't take the sine of 112, so you have to then like convert to a new triangle and rework out. So the point being is that hopefully that gives some motivation to redefine trig. So what I want to first emphasize here is, let me do something real quick. Here we go. What I want to first emphasize here is that when I asked you, like, so figure out what the height might be if the angle gets rotated into the second quadrant like that. And I've marked this point A for the location where the diver would be, and I want to recognize that, you know, A has an XY coordinate, and we got there by doing some rotation around the Ferris wheel, right? Let's look at some of the things we know about that point A. From here to here, this length from the origin to point A is the radius of the Ferris wheel, right? And this height is actually represented by the value y, isn't it? And so we can see that in this example over here, where the angle is still in the first quadrant and my point A with XY coordinates, we see the R labeled, and this length is length y. So in this case over here on the right, where the point A is in the first quadrant, I hope you see that the sine of theta is defined to be that length y over r. So in fact, why don't we just define sine as the ratio of the y coordinate to the distance from the origin to this point in the coordinate plane. I forgot what I was saying. So why don't we just define the sine of this angle of rotation to be the y coordinate, in other words, yeah, the y coordinate over that radius. So in fact, I'm kind of done. We will redefine the trig functions to be based on the coordinates of a point that follow rotation and a distance away from the origin. That's mostly the end of my video. I just wanted to try to make that strong connection. And I'm going to ask you to do a little reading next about just sort of restating those things that I said. So I hope that brief video was helpful. See you on Thursday.